All right, here we go. Proportion, similarity, congruence 1. PSC 1, lesson 1 objective. By the end of the lesson, you'll be able to do this stuff, set up some ratios, and solve some stuff. It'll be sweet. Let's go. All right, ratio is an expression that compares two quantities by division, written as, for example, maybe miles per hour. You're not typically seeing it like this, but that's what we mean. Or I don't know, points per game. Any ratio you can use there would be sufficient as long as it's using division. That's a ratio. Proportions, on the other hand, are equivalent ratios. Right? So 6/18 is equivalent to 1/3. An example of a proportion that you'd need to solve. It could be, all right, 10 is proportional to 20 as x is to 402. We're going to solve a few of those today. Example, we can use this to solve for the missing terms. If we cross multiply these, okay, let me try that in different colors. If we cross multiply 21 times 12, I don't know what that is, but 21 times 12 should be equal to 14 times x. So if you have a calculator available, I would use that to your advantage. 21 times 12, that's just evading me right now, 252. Okay, so 21 times 12 is 252. And 14 times x is exactly what you think it is, 14x. Now we would divide both sides by 14. And we would get that x equals hopefully a whole number. I think we will. Let's divide. Yep, looks like I get an 18. Cool. There's many different ways you go about solving those, but that's just one of them. All right, let's move on to a couple examples. Oh yes, good one. Dan is 2.5 inches tall, and his sister Emma is 1.5 inches tall in the photograph. Dan's actual height is 70 inches. What is Emma's actual height? So let's think of this as Dan and Emma. I like to lay it out. Dan and Emma, they aren't the same height. However, their ratios should be. So Dan is 2.5 inches tall in the photo. Okay, how tall is Dan in real life? Real Dan or actual Dan. Isn't there a movie called Dan in Real Life or something like that? I think there is. Okay, so he's 70 inches tall in real life. Emma in the picture is 1.5 inches tall. Okay, so now at this point, let's call it E for Emma. Okay, at this point, if you come up with a number for E that is greater than 70, there should be red alert going on in your head. Okay, so I'm going to cross multiply and take 70 times 1.5 and set it equal to 2.5 times E. Okay. 70 times 1.5, I think, is 105. So 105 equals 2.5 E. Let's divide both sides by 2.5. And let's see what we get. 105 divided by 2.5. Using my trusty little TI 30XIS. That's such a good calculator. So good at calculating things. So E is, what is that? 42. So what does that mean? Oh, E is 42. Well, she has a name, people. Her name is Emma. And she's 42 inches tall. She must be like 4 years old or 5 years old maybe, because my daughter's like 40. Yeah, she's like 43 inches tall, and she's a little below the curve, but she's a 5-year-old. Okay, so solve for x. Why don't you pause the video, go ahead and solve for x. When you come back, I'll work out some answers. All right, so I get 21 is equal to 2x. I divide both sides by 2. Looks like I get 10.5. That's an acceptable form. Another form that would be acceptable would be 21 halves. Either of those, good to go. Okay, over here, ooh, a little bit more to it. I'd get 3x is equal to, this is where you need to pay attention to detail, 4 times the quantity x plus 2. Okay, that's where children get sniped. But if I have a 3x, I'm going to distribute the 4, get 4x plus 8. That's where someone's going to jack things up. So it looks to me like I'd get negative x equals 8. So x, I'm not looking for negative x, I'm looking for x. Looks like x equals negative 8. All right, let's keep rolling. Okay, I'll give these a try. Same deal. Okay, it looks like I get 2y equals 3 times y minus 3. Okay, I'm going to distribute the 3 and get 3y minus 9. Looks like I'm going to subtract 3y from both sides. So I get negative y equals negative 9, therefore y equals 9. Superb. Okay, this one's a funky one. I like it. All right, 6 times 12 is, well, I guess I should write it out. X times x is, well, that'd be 72, and that'd be x squared. Ooh. Okay, a couple different ways we could go here. Let's go the JV route first, and then we'll go the varsity route second. Okay, JV route would be to just take the square root, and you get, oh, that's nice, square root 72. Now, if you were to estimate, if you didn't have a calculator available, and you were just to estimate what that would be, I think we can all agree it would be somewhere between the square root of 64 and the square root of 81, right? So that'd be between 8 and 9. That's a 7, and that's a 2. Yeah, very good. Okay. I would assume that it would be closer to square root of 64, so closer to 8. So I would guess like 8.4, something like that. That'd be a decent estimate. However, both of these answers would be acceptable JV answers, and you will get correct full credit on the test. However, if you want to take it a step further, and we're not going to do this until next unit, but if x equals the square root of 72, you can keep it exact by finding a perfect square that is a multiple of it. So 36 becomes 6 root 2, and that would be a nice little varsity answer there for you. Okay. Hopefully I didn't go too quickly, but if I did, go back and rewatch it. All right. Let me look forward here. Yep, just one more. Matt is drawing a floor plan for his new house. The conversion he is using is 1.5 inches for every 3 feet in the real world. What will the dimensions of his bedroom be if he draws it 5 by 10? Okay, so remember, 1.5 inches per 3 feet. Okay, so let's go length. And I spelled length wrong. That's great. Okay. So 1.5 inches is to 3 feet. Now, I'm not going to write 3 feet. I'm going to write 36 inches. And no, you know what? I'll write it as 3 feet. Oh, that was convenient. Okay, so this is on the, what does he call it? Oh, yeah, floor plan. So the floor plan size converts to a real size of this. Okay, and this is going to be for the length only. Right, so he made the length of the room 5 inches. And we want to know how many feet it would be. Let's see, is that going to be a problem? I don't think so. I don't think it'll be a problem. Okay, so let's go ahead and cross multiply. So 3 times 5 is 15. And 1.5 times x is 1.5x. I divide by 1.5. And it looks like I get 10. Okay, now some of you might be thinking, well, I can obviously see I double that, so I double that, and that's fine. You're technically not doubling it, though, because of the units of measurement, and that had me kind of reeling for a second, like, will that make any difference? And the answer is no, okay? But understand that this is inches, right? The floor plan is in inches, and the real portion is in feet. Therefore, okay, we get a 10. Now let's do the same process for the width. I think the width we still have the same ratio, 1.5 to 3 feet. But now the width, I think, was 10 inches on the floor plan. And therefore, we would find, let's say, y. Okay, you could go through the same process. 3 times 10 is 30, and 1.5 times y is 1.5y. But what you're going to see is you'll get 20 equals y. Well, same principle applies. I doubled that, therefore I doubled that. And therefore, the dimensions of the actual room are 10 feet by 20 feet. It's decent size room. Not real good, but it's decent. Okay, so a what is it? 5-inch by 10-inch diagram was proportional to a real life bedroom or dining room or whatever this was of 10 by 20. Okay, that's lesson 1. Don't forget to like, subscribe, and comment below. Thank you.